I used to give this talk a lot, especially to external groups. It normally takes about an hour to an hour and a half, so I've really scrunched it up to try and get it inside the time frame. So I don't think we're going to have time for questions, but please, if you do have any questions, either give me a call or send me an email. I'm all in this. I'm part of us. We're part of this. Okay, I wanted to call it the ins and outs of food poisoning and not food poisoning and its prevention, because I thought it was nicer. I've actually been asked to give you a quick history of Biotech Laboratories for those people who didn't know about us. It was originally the concept of Mark Tandy, who you may know, projects manager, and myself in 1988. Initially, we were going to do it outside of Sullivan-Nicolaides pathology. We were all planned. We had our letterheads made up, paper printed, our name registered. It was Biotech Laboratories. And at that time, Ron Morahan, who was head of pathology head of microbiology, came along. He was a really lovely guy, entrepreneurial type person. He came along and said, I think we can make money by doing Legionella testing on cooling towers. And our heart dropped. Anyway, after a period of not talking to each other and then talking to each other, he actually decided that he'd take it to the partnership, because remember, S&N, and that's why I call it S&N at that stage, that's what we were known as, and it was a partnership. It was approved for a trial to begin in 1989. That trial was done after hours, so after we finished our work, Mark and I originally alternated processing water samples. Later, Margaret McCowan, now head of quality systems, also came along, and the three of us shared the work. In 1st of July 1990, the whole enterprise was taken over by Sullivan-Nicolaides, went to the partnership. We didn't get any shares, I don't have any shares. It's all totally owned. So we're really just another department out of Biotech, out of Sullivan-Nicolaides pathology, in my mind. And we're now incorporated, so it's Biotech Laboratories Proprietary Limited. Okay, that was in 1st of July 1990. We got our biological NADA accreditation, which makes medical accreditation look like let's go down to the pub and have a few drinks. Believe me, biological beats the hell out of medical as far as difficulty in doing it. In 1992, I resigned as head of the microbiology department, which was what I was at that stage, doing both roles. I became general manager of Biotech Laboratories, and Mark Tandy took on the role of microbiology department head. Shane Byrne, know that name? Was our first ever lab assistant. So anyone who's ever had anything to do with Biotech Laboratories becomes a senior manager inside. So if you want to move up in this whole you've got to talk to me. We started off at Spring Hill in Leichhardt Street. We moved to Taringa, and then we were kicked out in 2000 because we were taking up too much space. And now we're in LG1. And apart from Bob the Builder, there's nobody else on LG1. And July. We now employ about 18 staff. We process food, water, environmental samples, swabs, soil and all that, mainly for microbial analysis. Okay, ins and outs of food poisoning. My qualifications, BSc, Bachelor of Applied Science from QIT, thank you, not QUT. Started at Sully & Nix in 1978. Do not put your hand up to say you were not born at that stage. I've got a BSc from the University of Queensland after that, and I was department head of microbiology from 81 to 92 and from 1990 onwards. Okay, put your hand up if you've ever had food poisoning. Good. I'm sorry, it's like Simon says, I didn't actually say put your hand down. Put your hand up if you've ever had food poisoning. Thank you, thank you. Keep your hand up, keep your hand up if you've had it twice. Twice? Excellent. Now let's go 3 times. 3 times, and I'm talking pathology proven, scatter patterns on toilet bowls to make the average CSI technician excited. Okay, 3 times, 4 times with food poisoning. Okay, look around the room. Who's still got their hand up? Forget about all my qualifications. They don't count for absolutely anything. I've had food poisoning 4 times. I'm the expert, okay? So I know what I'm talking about. Twice with Salmonella, twice with Campylobacter. Okay, classical food poisoning. It's not nausea, it's not fever, it's not, oh, I've got a headache or I've got a pain in my stomach. That's not food poisoning. You need vomiting and or diarrhea. Okay, the exception to that is a bug called Listeria monocytogenes, which I'm not going to talk about today because although it is a food-borne and it is a pathogen, it doesn't cause this vomiting diarrhea. It's a very important bug, but it's not important as far as the causing of classical food poisoning. Okay, there's 2 mechanisms. You can ingest the viable organism. So there we've got a list, Salmonella, Shigella, your different pathogenic E. coli, Campylobacter, your different Vibrios, which are usually associated with seafood, Clostridium perfringens, everyone thinks of it as causing gas gangrene and all that sort of stuff. It's actually a food poisoning bug as well. And these you need to ingest a living bug for it to cause things. Viral, you can get person to person, but it can be associated with seafood. I don't know if anyone remembers an outbreak of hepatitis through oysters in northern New South Wales a number of years ago. It was because there was fecal matter in the water that they were being farmed in, contaminated with hepatitis, and it doesn't infect the oyster. Oysters are filter feeders. They just suck the stuff out. So it was just sitting in there. If they'd waited another 2 or 3 weeks, it would have been flushed out, but they harvested them too early. Okay, the other way is you actually ingest a toxin or a chemical. And there's a number of bacteria that do that. Staph, we call it coagulase positive in our industry rather than Staph aureus. Staph, Bacillus cereus, Clostridium botulinum, from cans, it doesn't really happen anymore, are the main bacteria. Ciguatera from seafood, your toxic mushrooms and your different chemicals. Okay, it's not the bug, it doesn't need to be living, it's a toxin produced by that thing. When you ingest a viable organism, your incubation time is generally longer as compared to when you're ingesting the actual toxin. More often you do get vomiting and diarrhea when you've got an ingested organism. With a toxin, there's actually 2 strains of Bacillus cereus. One only produces a toxin that produces vomiting. The other strain produces a toxin that only induces diarrhea. It's quite unusual. With staph, you generally get both. And obviously, when you ingest a viable organism, parasite or whatever, fecal samples to a path lab should lead to a diagnosis. With these things, basically, fecal samples are useless. So once upon a time, we used to think whenever we got a good liquid stool coming in and we got negative, it was probably a viral infection because we didn't test for it. Whereas now, you're probably looking more likely that it was actually an ingested toxin as well. Okay. When we're looking at the causes of food poisoning, you're looking at the ingesting a viable organism, the first thing is highly contaminated foods. Now remember, cooking isn't sterilisation. If you want to eat sterile food, eat food out of a can. That's sterile. Everything else you eat has got bugs in it. The sandwiches outside would have, on average, I didn't have one, but I would have. No, I did. I had about 5 or 6. An average in every gram of a sandwich, you're getting about the bacteria of around about 10 million, 1 million to 10 million bacteria in every gram of a salad sandwich. Okay? Bugs are everywhere. When you cook, cooking doesn't sterilise. So what it does is it will do somewhere between a 2 and a 4 log phase kill. Now that means if we started with, say, 1,000 salmonella per gram in a food, if you got a 3 log phase kill, we're taking off 3 zeros, okay? Or 2 log phase, 2 zeros. So you're looking at a 3 log phase kill would take 1,000 salmonella per gram, put it back to 1 per gram, okay? And all of these bugs have infective doses. If you've got salmonella down to 1 per gram, you're going to have to eat, kilos of it to actually get salmonella food poisoning. So there's an infective dose. But if you're starting with food that's been highly contaminated for one of a number of reasons, and you're starting off with 100 million salmonella per gram or Campylobacter or whatever, then your normal cooking won't get it down low enough and you're going to get sick. You can get cross-contamination before consumption of ready-to-eat foods. There was an outbreak at a restaurant where everyone who had the salad on a particular couple of days, side salad, everyone got sick, and it was Campylobacter. You don't get Campylobacter or salmonella in vegetables. It doesn't occur. It wasn't until they went back inside the restaurant that they found a colander sitting on the top with liver sitting on it. That was fine. It was in a nice bowl that was catching all the juices, which had overflowed, dripped down through 2 levels of the shelving onto the box of lettuce down the bottom. Okay, be very careful about that, that side of things. Improper cooking, obviously not cooking things evenly or all the way through where it's necessary. Temperature abuse before, we've talked about, that'll push that level up by temperature abusing a product before cooking or in fact after cooking. You may have decreased the salmonella count down to a low level, but you've gone and let it sit at room temperature for extended periods so they start to grow up again. Remember, they divide in 2 and then 4 and then 8, 16, serology, 32, 64, 128, 256. I can't go past that. Okay. And you can get post-cooking contamination. You go and get your raw chicken, you put it on your cutting board and you chop it all up, and then you cook the chicken and you take the cutting board and you rinse it under the tap. Bacteria can swim, okay? They don't drown. And then you bring it back out and you take your chicken and after cooking and you cut it up on the same board, or you rinse that board and you use it to chop up your salad vegetables. Food poisoning, here I come. In all of those situations, further proper cooking will make the food safe. So even if it's contaminated, if you went back and recooked it, you're going to make it safe. When you're looking at a toxin, the presence of, it can either be a chemical or a non-microbial toxin. You can have microbial, again, it's highly contaminated food. So we've got the staph or the bacillus sitting in the food and it's growing up. And as it's growing up, it produces the toxin. Okay? Temperature abuse after. You can reduce the staph or bacillus level down, but you've got to leave it sitting at room temperature. And therefore it starts to grow again, and then it gets up to enough numbers and it produces a toxin into the food. It's the toxin in the food in this situation which is a problem. Further proper cooking probably will make no difference at all. You can go and kill the bug, absolutely wonderful. The toxin's heat stable. So once you've abused it in that way, you're gone. You're looking at a weight loss program for a number of days. It's the toxin that causes the symptoms. It's released by the bacteria after they attach to the colon when you ingest viable bugs. So the salmonella and the Campylobacter and the Clostridium, they get down to the lower colon, they attach there, and then they start to grow, and then they produce the toxin at that stage. When you're ingesting it, the toxin's got to find its way down to that point. Okay, as soon as it hits there, it starts to affects the permeability of the colon. That's all that's happening here. It affects the permeability of the colon. Normally, water in our feces is absorbed into the body, and comes out as normal formed stools. For those in micro, we love that term. We used to put the sample description of the feces on our reports. Do they still do that? Any micro people here?
Yeah, we do.
You do? Formed, unformed, liquid. Oh, I made up some of those codes. Anyway, okay. What happens when the toxin gets in there? It affects the permeability. So what in fact happens, the reverse happens. The body is pumping water, because the permeability is broken, into the alimentary tract. And that's what causes diarrhea. The bugs don't get in there and produce water. It's just the toxin And that's where diarrhea comes from, all the water coming out of the body, which is why you always get told by doctors to, drink those disgusting electrolyte drinks and keep the water volumes up, because you're constantly losing water. And that's where initially you lose all the weight. It's just loss of water, and that's why it often comes back pretty quickly. There used to be an ad, I don't know if people remember, there used to be an ad for a curved toothbrush, and it had this naked guy standing there, and he said, if we all had a flip-top mouth, we wouldn't need this toothbrush, okay? So if we removed that toothbrush and we got on a chair and we stood up and we looked down that guy's mouth, okay, you can't see the floor, okay? It's not a downpipe. You don't eat a food and you get diarrhea at the same time and go, oh, that was it, okay? It doesn't work that way, okay? There's something like 5 metres between the mouth and the end of the colon, the anus, okay? It's got to work a long way before it gets to the area where it starts causing infection. Toxins are still usually over an hour, but it can be, over 6 hours. They can be as short as 1 hour, but it's relatively rare. Bacteria are usually at least 12 hours. There's a couple of recorded cases of 4 to 6, but that's really looking at massively high bug levels and often something else going on. Parasites 1 to 25 days, viruses 12 hours to 3 days.